make sure it's recording. So as for my project, I wrote it in Java and C because Java times were giving me weird, and then C was not too different, so I just stayed in Java. I have two Javas I'll show you. The first one is for counting the actual time it takes, and the second one is counting the recursions. So this first one, for time, so I output the results to CSV files to plot in MATLAB. So this creates set for the size of the array to input to create the array from 5 to 100,000, so 20 times. It's for printing the screen, closing the file, globals, since Java doesn't have globals technically. So this creates the array, so I input the array size above from that for loop, and then it fills it with random numbers between 1 and 100,000. Yep. Then it sorts it, and then this is for the search number, creates a random number between 1 and 100,000. So then counts the time for binary search and for ternary search. So this is this, and then it puts it in the array, the global array, to output to the CSV file. Same for the ternary search, different global array. And then here's the binary search, and these two are the same, except I just take out the time and add a recursion count. So this is for binary search. Obviously, if it's low is greater than high, then you're done. And then cuts it in half, and then if the number is below the first half of the sorted array, it recurses through the first half. If it's greater, it recurses through the second half of the array. And then if it's equal, it's found. And then ternary search, obviously the same. In case separates it into 3 points instead of 2, so there's 2 midpoints. So if it's equal to either of the midpoints, it's found. If it's less, it goes to the first array. If it's greater than the last, it goes to the last array, and then whatever is left, obviously the middle. So if I run this, so this is the output size of the array, and then if it found it or not, or returns null if it doesn't find it. So numbers found, obviously it searches the same array and the same number for binary search and ternary search, so it would find it at the same time. And then this is time taken, and I scaled it to match the log scales to graph with the theoretical and the actual time taken. So when I plot it in MATLAB, so this is the binary search and the ternary search. There's folders in there obviously as like this, so binary and ternary. And then, oh, that's commented out. I'm going to comment out this is for the recursion. I'll show that after. So this is binary search, ternary search, graphing it with n arrays from the size of 5,000 to 100,000 in increments of 5,000, and then I graph it with log base 2 for binary search and log base 3 for ternary. And the log files, I just created CSV files because that was easiest. So when I plot these, so as you can see, this is why I ended up doing the recursion in C, because the times are all funky, but follows the general idea. I'll show you again so you show that it changes. So this is the same one, plotting again. And then if I run it again to create new CSV files, obviously did the same sort of idea, and then I run it. Okay, ternary search, you can see they're different graphs because it was different numbers. And then binary search in the title, different graphs. So that's that. Let's open that back up. So here is for the recursion. So as I said, writes to a different file, binary search 2 and ternary search 2. All this code is the same as I said, except around the function when I run it here, binary search and ternary search, I don't account for time, comment it out. And then just in the recursions, I have the global, and it counts each time it goes in the recursion, and it'll reset it. Same logic for binary search, and ternary search is the other one. So when I run it, same idea happens. Size of the array, no, bunch of nulls. And then when it found the number, and then this is the number of recursions it took. So if I go to MATLAB, and you can see here binary search 2, ternary search 2, like that. And those are just BS2 and turn 2. So if I comment out this first one, that was for time, and uncomment this second one, that is for recursions, the BS2. Turn 2 with the same logs as the other one, obviously. So, whoa, that one is weird. So here's binary search, and then, whoa, found it. So I'll run it again, show that it's different, and I'll probably get a better one. There's not a bunch in a row like that. A little better. Alright, run. So here's for the ternary search. You can see they're different graphs. Man, these are just terrible. Alright, that follows it a little better. And then drops. That is the same graph. Oh, no, it's not. It's way different. I ain't be fibbing. So there's that and that. I'm gonna run it one more time, get a little better results. Let's try it. Of course my MATLAB won't open. I don't know. Frozen. Dude, there we go. Alright. What the heck, man? Well, you can see it follows a general line. This one, little bit. One more time. Run. Things be funkin' tonight. Hey, that's better. So you can see, follows a general idea. And I did. Yep. So that's that. And then the C, I won't show you that because it is the same. Basically, the graphs look the same. Thank ya. Bye. Turn off.